Hi everyone, this is Ms. Chow and I'm going to talk to you about section 7.3, deductive reasoning. So the last two lessons or sections have been about inductive reasoning and using inductive reasoning to find a specific term and then to find the nth term. Well, today we're going to talk about deductive reasoning, which is kind of different but opposite of inductive reasoning. So I'll start out with a quote. So it says, "Contrariwise," continued Tweedledee, "if it was so, it might be. And if it were so, it would be. But as it isn't, it ain't. That's logic." Lewis Carroll, Through the Looking Glass, and that's about Alice in Wonderland. So that's sort of goes to show what can come about as you start to pontificate on deductive and inductive reasoning. So to start with deductive, I want to show you a slide about the differences between deductive and inductive reasoning. And the first one here, let's see if I can get this up on a... Yeah. So in general, we've been looking at inductive reasoning. And inductive reasoning is what they call bottom-up reasoning. In other words, where you make repeated observations and then generalize those observations. So for example, we studied series and sequence, and we made repeated observations about each number and its term and its resulting number. So that's called inductive reasoning. Deductive reasoning is different. It comes from the top down because it starts with a concrete premise, and then it goes on to substantiate the premise with more ideas, and it leads to conclusions. So it's whether you start from the bottom up or the top down. Now these two gentlemen here on this slide, the guy on the left is Aristotle, and Aristotle sort of coined deductive reasoning thousands of years ago. And then fast forward a couple thousand years, and this is Sir Francis Bacon. And Sir Francis Bacon then came up with or coined the inductive reasoning idea. So that's pretty interesting stuff, isn't it? In your math class. Yeah, baby. Okay. So, and then I'll just give you a definition from the book, which is deductive reasoning is a method of drawing conclusions from facts that are accepted as true. That's the top-down piece. The flow of logic starts from the more general and leads to the more specific. And it's called a top-down approach and works the opposite way from inductive reasoning. So the way we're going to test this out are the three steps. So you begin with an accepted fact, and then continue step by step with statements using logical reasoning, and make sure each statement is in sequential order and leads to a clear solution. So here are some ways to think about it. So all people are mortal. So this was Aristotle's thought, actually. He said all people are mortal. Mr. Willman is a person, therefore Mr. Willman is mortal. Oopsie, I gotta find the color. Therefore, I'll call him Mr. W, is mortal. Okay, all dogs are mammals. All mammals have kidneys. Therefore, all dogs have kidneys. All students eat pizza. Nolan is a student at Lord Byng Secondary. Well, I don't know that. I made that up. But nonetheless, he could be a student at Lord Byng Secondary. So therefore, Nolan eats pizza. Okay, all numbers ending in 0 or 5 are divisible by 5. The number 35 ends with a 5. Therefore, 35 is divisible by 5. Now, note how these are going here. So the first sentence is the concrete accepted fact. all numbers ending in 0 or 5 are divisible by 5. So that's a fact. And then the number 35 ends in 5. Well, that's obvious too. So therefore you can say 35 is divisible by 5. Now, but think about what would happen if things go wrong in one of these steps. So I'll do one more and then we'll go down to invalid reasoning. So all birds have feathers, all robins are birds, therefore all robins have feathers, right? Okay, if we move down to invalid deductive reasoning, here's where it gets a little sketchy. So the first example is all swans are white. And then it says Jane is white. Well, therefore Jane is a swan. Okay, well, first of all, I don't know for sure that all swans are white. I think they're all white. And even if they are, Jane is white. Caucasian, I suppose. But you've got the whole wrong species here. Like you can't go from this one to this one. And therefore Jane is a swan. Well, that's not the case. Here's another one. All farmers like burgers. Jethro likes chicken wings. Therefore, Jethro is not a farmer. Well, what do we know about Jethro from this sentence? We know he likes chicken wings, but we don't know if he likes burgers or not. So you're not really sound in any of these situations. The last example. All basketballs are round. The earth is round. Therefore, the earth is a basketball. Well, here again, you're sort of mixing your metaphors because you can't say necessarily that you can't say this at all. So that's just ridiculous. But anyway, so that's where it can be invalid and it can go wrong. Now if we talk about counterexamples, a counterexample is an example that disproves a statement or proposition. And you only need one counterexample to disprove a statement. So you don't need 3 to say, oh, that's going to be false. You only need 1. So determine which of the statements is true or false. If false, state a counterexample. So every number divisible by 6 is divisible by 3. Well, in this case, we actually know that 6, the prime factorization of 6 is 2 and 3. So therefore, we know that if it's divisible by 6, it is in fact divisible by 3. So we know that one to be true. Or I can't think of any other, any false statement. The second one, a number greater than 12 is divisible by 12 if it's divisible by both 2 and 3. Well, in this case, maybe we should start out thinking about the numbers that are divisible by both 2 and 3. So, and the one that comes to mind is 18. 18 is divisible by 2 is 9, and by 3 is 6. But it's not divisible by 12. So here's my example of, or my counterexample of this one. A number is divisible by 18 if it is an even number divisible by 9. So 9, 18, let's just do a few here and make sure. 18, 9, 27. What comes after 27? 36. So it looks like this is going to be true because I can't see any numbers in the near future that would disprove this. So this one would be true. And then the last one, if a number is divisible by 2, then it is also divisible by 4. Well, we sort of know from above that that can't really be the case because a number could be divisible by 2, say 6. 6 is divisible by 2, but it's not divisible by 4 unless you want something that's a non-integer. So, so this one I'm going to say no, and I'm going to use the example 6. Okay, before we go to homework, I want to talk about these inductive reasoning versus deductive reasoning. So in this first case, inductive reasoning, and it reads, the first candy I pulled from my bag is red. The second candy I pulled from my bag is red. See, this is sort of like our series questions before in the second chapter. Therefore, all the candy in my bag are red. Well, the first candy was red and the second candy was red, but that doesn't necessarily mean that all of the candy is red. So I think that's kind of a leap. But deductive reasoning says, the first candy I pull from my bag is red. All candy in my bag are red. Therefore, the second candy I pull from my bag will be red too. So that's actually quite sound. So that's a good one. Inductive reasoning. My mother is Irish. She has blonde hair. Therefore, everyone from Ireland has blonde hair. You can't really say that. But deductive reasoning. My mother's Irish. Everyone from Ireland has blonde hair. Therefore, my mother has blonde hair. Well, that makes sense. Reasoning. Most of our snowstorms come from the north. It's starting to snow. This snowstorm must be coming from the north. Well, I would say that could be true, except that you really just aren't basing it on very much information. I'd like a few more data points. So here, for deductive reasoning says, all of our snowstorms come from the north. It's starting to snow. Therefore, the snowstorm is coming from the north. So that is quite solid. And then I'll actually go on the YouTube with you, but I want first to show you. So Sudoku is a very good example of what kind of reasoning. And the way I think of this is, if I put 1 in this square this time, can I pretty much assume that I'm going to put 1 in this square the next time I play? And that would be a definitely not answer. So this would be deductive reasoning. Okay, so at this point, I want to talk to you about the homework, and then I want to go over, maybe we can watch the YouTube together. So the homework is section 7.3, page 259, number 1, the odd letters, number 2, all of them, and numbers 4 through 12, all. Okay, so let's go to this YouTube and see what happens.
There are 2 types of reasoning that we use in geometry: inductive reasoning and deductive reasoning. And often we like to compare the two. Deductive reasoning is the process of reasoning logically from given statements to a conclusion. So let's say you wanted to have a later curfew. To justify it to your parents, you're going to have to use deductive reasoning and say something along the lines of, I'm a responsible person, I get good grades, I've been able to honor every other curfew. So basically you need to back yourself up to make your statement that you think that you need a later curfew. To give you a little more idea of what is deductive reasoning compared to inductive reasoning, let's say I asked you to prove that this quadrilateral QUAD is a parallelogram. And I told you that QD is parallel to UA, and that QU is parallel to DA. So if I just mark these, that QD parallel to UA, and that QU is parallel to AD, this process of what you would use, a proof, that is called deductive reasoning, because you're using given information to make a proven statement. Now, to compare this with inductive reasoning, let's say I gave you these 3 shapes, and I said, draw the next shape in this sequence. Well, you're going to see that we have an equilateral triangle, an equilateral quadrilateral, and an equilateral pentagon. So you're going to observe the pattern that all of these shapes are going up in one number of side, and that the sides are all congruent. It's an equilateral figure. So you know that the next shape in the sequence will be an equilateral hexagon. There, you didn't have a given statement, you didn't prove anything, you just saw the pattern, and you reached a conclusion of what the next shape would be. So this would be inductive reasoning. If you're ever given a quiz question where it says, is this inductive or deductive reasoning? Ask yourself, are you being asked to prove or show something? and justify it, or are you just observing something and making a conclusion based on patterns that you see? And that'll tell you if it is inductive or deductive reasoning.
Okay. So, and then these are examples. Oh yeah. I think I put most of these examples in the sheet, but if you'd like to look more, this is very helpful information. So, and it also even brings up other types of reasoning. So anyway, this website link is a good one, and I will put it out there for you so that you can have a look. Alrighty, well, thank you all for joining this session, and I hope you have a great afternoon.